Hi, I'm Ian Muffet, and I'm 16 years old.
And I'm Alan Paddlestad, and I'm also 16. Our experiment is concerning the properties of a magnetic fluid called ferrofluid.
This is ferrofluid. This is also ferrofluid. Ferrofluid is made of three key ingredients, the first of which is some ferrous metal, iron, nickel, or cobalt, that has been ground up into nanoparticles.
The second is what's called a surfactant. It holds onto the nanoparticles and attaches them to the medium.
Which brings us to our third and final ingredient, the medium. The medium is just some liquid that adds volume to the solution.
Due to the atomic properties of the medium and the surfactant, they don't mix, and so the nanoparticles can be extracted from the solution, maintaining a magnetic fluid. It is safe to transport to the ISS because there are no hazardous materials, no carcinogens, and it has a very high boiling point and flash point.
When neodymium magnets like these are introduced to the ferrofluid, spikes and valleys form along the poles of the magnets, like this.
The reason for this isn't fully known, but it's thought this because the magnetic field doesn't transfer well between drastically different materials, such as the fluid and the air, and so it has the tendency to be carried along only by the fluid. Once it reaches the surface, it pulls a little bit of the fluid with it, forming the peaks, but gravity, along with surface tension, restrain it, forming the valleys.
Because gravity is thought to be one of the forces that inhibit the growth of the spikes, we predict that when introduced into microgravity, the spikes will grow much larger.
Our method is to transport 60 cubic centimeters of ferrofluid in a sealed cylindrical transparent container to the ISS, along with the neodymium magnet. Once there, an astronaut will introduce the neodymium magnet with the poles parallel to the cylindrical container at the bottom of the cylinder. He will then measure the difference between the top of the peak and the valley along the poles.
We will then compare the data received from the ISS and the data received here on Earth and see how microgravity affected the ferrofluid in space.